Look around you right now. Maybe you are looking at your desk, a coffee mug, or just the wall of your room. It all looks perfectly still, right? You've seen these things 1,000 times. They just sit there, quiet, completely frozen in time. That is just how the world works, and that is all you need to know. Wrong. That stillness is a complete lie. It is the greatest illusion your eyes play on you every single day. If you could zoom in close enough, you would not see silence. You would see a frantic, jiggling dance of invisible pieces snapping and vibrating together with relentless energy. In the next few minutes, we are going to peel back that illusion. We are going to discover something so beautiful, so chaotic, and so deeply connected to everything you touch that it will completely change how you see the physical world. Think about the universe as a deeply strict accountant. It operates on a very rigid budget of energy. You cannot just have things changing, moving, or bursting into chaos for free. Everything demands a tiny down payment first. Take that seemingly quiet piece of wood sitting in your room. It is surrounded by oxygen. The atoms in the wood and the atoms in the air are constantly bumping into each other, millions of times a second. And here is the secret. They desperately want to be together. Carbon and oxygen are like long-lost friends. If they get close enough, they will violently snap together because being together is their ultimate comfortable low-energy state. But they do not do it. They just bounce off each other and drift away. Why? Because the universe says they do not have the budget for it yet, and there is an invisible wall between them, a barrier of energy. To get to that comfortable state, to finally lock arms, they first have to push past their current boundaries. They have to wiggle and fight their way up a very steep, microscopic hill before they can fall into that deep valley together. Right now, sitting at room temperature, they are broken. They only have enough energy to gently vibrate in place, completely unaware of the massive potential they are holding back. They are trapped by this fundamental tension. It is a quiet stalemate that can last for centuries. The wood just sits. The air just floats. So, what happens when we suddenly give them a little loan? How do we push them over that invisible edge? You bring a lit match to the wood. But what is a match really? It is not magic. The flame on that match is just a bunch of atoms already jiggling around incredibly fast. When you hold it to the wood, you are doing one simple thing. You're giving the carbon and oxygen atoms that energetic loan we talked about. You're forcing them to jiggle violently. Suddenly, a few of those oxygen atoms are moving so fast that they finally fly right over that invisible barrier. And then, snap. They lock onto the carbon. But this is not a gentle connection. It is a violent, aggressive crash. They snap into a new, tighter geometric shape, and in doing so, they thrash and vibrate with tremendous force. Think of a heavy mousetrap snapping shut. It does not just close, it shakes the whole table. Now, that furious shaking hits the atom right next to it, and making it jiggle faster. Now that neighboring atom has enough speed to climb its own hill. It snaps, it shakes, it hits the next one. One collision triggers two. Two triggers four. Within a fraction of a second, you have a beautiful, terrible catastrophe. Billions of atoms snapping into new shapes, thrashing around, and feeding off each other in a runaway chain reaction. There is no little engine inside making heat. It is just geometry and motion. That furious, relentless jiggling spreading outward, that is exactly what you feel when you hold your hands out to get warm. That is fire. But watch what happens as the fire burns. The log gets smaller and smaller until almost nothing is left but a tiny pile of ash. If all that solid, heavy wood is violently snapping together with the air and floating away, and it leaves us with a very strange question. Where did all that massive stuff that made up the tree actually come from in the first place? If you ask someone where a giant, heavy tree comes from, they will almost always point down. They think it grows out of the dirt. It makes perfect sense, right? You put a tiny seed in the ground, and decades later, a massive structure is standing there. But just look closely. If that huge trunk and all those heavy branches were pulled up from the earth, there would be a massive, gaping crater in the ground around every single old tree, but the ground is flat. The dirt is still there. So, where did all that solid mass actually come from? Here is the beautiful twist. It came out of thin air. It is almost impossible for our brains to accept, but that heavy, solid piece of wood is mostly made of carbon, and the tree pulled every ounce of that carbon directly from the invisible breeze blowing through its leaves. And the air is full of carbon dioxide, which is just carbon and oxygen atoms tightly locked together. Remember how we said those atoms desperately love being together? They are in their perfectly stable, comfortable state. Pulling them apart is incredibly difficult. A tree cannot simply pull them apart on its own. It needs a massive influx of energy. It gets that energy from 93 million miles away. The light from the sun comes crashing down from the sky, hitting the leaves of the tree. That sunlight is pure, frantic energy. It strikes those carbon dioxide molecules and violently forces the carbon and oxygen apart against their will. The tree breathes out the oxygen back into the air, and it takes that isolated carbon, stacking it up, atom by atom, to build its wood. That heavy log you just threw on the campfire is not frozen dirt, and it is literally spun from invisible air and woven together by the brute force of a star. The wood is holding all those carbon atoms in a state of suspended tension, just waiting for the chance to reunite with the air. It is a physical battery of trapped light. So, when you strike that match and finally let them snap back together, what do you think is actually rushing out to warm your hands? So, when you sit by a fire, you aren't just looking at burning wood. You are witnessing the grand unfolding of a cosmic storage and release. All that heat, that intense light, that flickering orange glow, it is literally the stored sunlight of years past. The tree spent its whole life painstakingly capturing the sun's energy, using it like a hammer to drive carbon and oxygen apart, just so it could build itself out of thin air. When you light that fire, you're reversing the process. You're letting those atoms snap back together, and the energy that was used to keep them apart is suddenly kicked back out. It's sunlight and sun heat, stored in a log, released for you to feel today. It makes you realize that the world isn't just a collection of objects. It's a massive, interconnected flow of energy that never truly disappears. And it just changes shape. But then you have to wonder, if all this energy on Earth is just a small loan from our star, where does the sun get its own endless supply of jiggling, roaring power? How is it that the sun stays so hot for so long without ever running out of breath? That's a different story, and I'll leave you something to imagine. But here is where things get truly chilling. Many of you have commented that this feels like we're living inside a simulation. And if that's true, the speed of light isn't just a speed limit. It's the refresh rate of reality. It is the guardian of causality. You see, we often think of light as something that helps us see across distances, but its real job is to protect the logic of the universe. It ensures that the cause always happens before the effect. What happens if you try to cheat? What if you could wiggle your way past that cosmic speed limit, $C? If you could send a signal faster than light, you wouldn't just be moving fast. You'd be moving backward through the narrative. You could send a message with today's winning lottery numbers to your yesterday self before the balls were even drawn. Yet you'd see the egg shattered on the floor before it ever fell from the table. That is a logical catastrophe. It's a pop-in error in the software of existence. If the sequence of this happened, so that happened breaks, the entire structure of the universe collapses into a heap of nonsense. There is no story without a sequence. The universe is incredibly strict about this. It doesn't care about your desire to travel to the stars or win the lottery. It cares about preserving its own internal logic. It demands that the sequence remain unbroken, that the why always come before the what. It's as if there's a divine set of rules, a fundamental code that says, do not break the logic. We are all participants in a grand, unfolding story where every snap of an atom and every flicker of a flame follows a script written in the very fabric of space-time. It's a bit frightening, isn't it, to realize we are held within such a rigid, perfect order. But there is also something deeply comforting in knowing that the universe is not just a chaotic mess. It is a masterpiece of absolute, unbreakable law. I'll leave you to think about that the next time you look at the stars. Are we looking at the past, or are we just watching the simulation load its next frame? That's something to imagine. So, the next time you sit by a fire or simply feel the warmth of the sun on your skin, remember that you aren't just an observer of a random world. You are part of a giant rhythmic dance of energy that has been unfolding for billions of years. We think we understand the ground beneath our feet or the air in our lungs, but as we've seen, the truth is often much more poetic and much more strange than we ever imagined. It's humbling, really, to realize that a tree is made of captured starlight and invisible breath, to realize that the speed of light is the only thing keeping our reality from falling into a chaotic glitch. We spend so much of our lives looking for meaning in the big things, but the most profound secrets of the universe are hiding right there in the jiggling of an atom or the snapping of a carbon bond. But this leaves us with one final, nagging mystery. If the universe is so careful to protect its logic, and if energy is always just shifting from one pocket to another, where did the very first spark come from? How did the big accountant of the universe get its starting capital? How did the first atoms learn to jiggle in the first place? That is a story for another time. For now, I'll leave you with that to imagine. I'll leave.